Hi, it's Marco from Donut Lab. You are watching our battery proof series called I Donut Believe. In this series, we demonstrate the capabilities of Donut battery, which is the world's first solid-state battery used in production vehicles. Today's topic is hot performance test. In this episode, we prove that the cell can remain stable in conditions that are almost double what typical lithium-ion cells can operate in. These conditions are 80 degrees Celsius and 100 degrees Celsius. Now let's go and watch the test.
Thanks, Marco. We're back at VTT Battery Lab looking at independent third-party test results of the high temperature performance test. VTT is a government-owned technical research center of Finland. The full report made by VTT is again available to download at idonotbelieve.com. So let's dive in. As we know, lithium-ion requires very careful temperature control to avoid damaging and accelerating aging of the cell, but also to avoid the worst-case scenario of thermal runaway. This means lithium-ion batteries have a very narrow operating window as it comes to temperature, limited to maximum 60 degrees Celsius or sometimes up to 70 degrees, making operation like fast charging in hot ambient temperatures a real big challenge. Much like in the fast charging test, we are again taking temperatures much higher, and the cell can still easily discharge with 1C. In the charging test we showed earlier, you might have noticed in one of the runs we hit a safety limit of 90 degrees Celsius and needed to run that test again to get proper apples-to-apples comparison data. But it's important to note that this was not a safety limit defined by the cell, but instead just a very conservative safety limit for that particular test setup. Today we're taking it even higher and showing how the cell operates safely in 100 degrees Celsius for extended periods of time and can even access more energy capacity than in room temperature. This test setup is quite simple. The cell is sitting on an aluminum profile and a steel plate is placed on top of the cell to provide a gentle amount of pressure to keep it in place and to reduce hotspots like a battery pack structure would. The test started with a standard 1C discharge capacity test with constant current until 2.7 volt cutoff. Starting with the same standard capacity test for every independent test sets a benchmark capacity for the cell in room temperature, but it also proves that the cells under testing are indeed exactly the same. The same capacity, same voltage curve, same dimensions physically, with some slight variance in measurements expected due to slight differences in testing conditions. Let's first talk about the 80-degree test. After setting the benchmark capacity, the cell was charged back up to 4.15 volts in room temperature. Then the chamber temperature was raised to 80 degrees Celsius and kept there for 2 hours for the cell temperature to stabilize. Then the same 1C discharge capacity test was repeated to get a comparison number in 80 degrees Celsius. After that, the chamber was cooled down and kept there for 1 hour for the cell to cool down completely, and then it was charged back up to full. Then let's move on to the 100 degrees test. After 1 hour idle period, the cell was discharged using 12 amps to the same 2.7 volt cutoff to set a benchmark 0.5C capacity in room temperature. The cell was then charged back up to full, followed by a 1 hour idle period, and then raising the chamber temperature to 100 degrees Celsius. After letting the temperature stabilize to 100 degrees Celsius for 2 hours, the same 0.5C discharge capacity test was repeated. And finally, the chamber temperature was lowered back to room temperature and the cell was charged back to full to make sure it still accepted the same charge capacity and continued to work normally. So what about the results? In 80 degrees, the cell could access about 10% more of its energy capacity compared to room temperature before reaching the 2.7 volt cutoff. This is because the cell's internal resistance keeps dropping even at these temps, meaning the voltage drop during discharge is lower than in room temperature. And the behavior at 80 degrees Celsius appeared fully stable with no observable changes to the cell, indicating that this temperature range does not introduce instability in the tested configuration. After multiple hours in 100 degrees Celsius, the cell could access around 7% more of its capacity in 100 degrees compared to room temperature, and also charged back up to full with the same charge capacity as in room temp. We can see that the active materials are still fine because the cell operates normally even though the outside pouch has lost its vacuum in the heat. It's also worth emphasizing that there was basically no rise in cell temperature in either of these tests. Overall, we can see that the comfort zone of the donut battery reaches much higher temperatures than a conventional lithium-ion cell. It continues to operate in a stable manner and reaches more capacity in 100 degrees Celsius than the nominal capacity in room temperature.
That's everything. Thank you for watching. The full report is available for downloading at idonutbelieve.com. See you next time.